I am Aishman Vadiyal.
And I am Arushi Julia.
This is our mega project SI EPM.
So now, as you can see here, I have a broken Arduino, and when I put it in front of the camera, it is able to detect it. And the e-waste manager over here is also able to detect it as it is an e-waste.
Now, after some time, this will close and the processing of the e-waste starts. There is a nichromium coil which heats the e-waste at a very high temperature, thus segregating the plastic, which turns into molten plastic from the metal, which does not get melted as it has a very high melting point. And as you can see, we have integrated some sensors into our machine, such as an ultrasonic sensor, which tells us the volume of the current waste in the machine, along with the DHT, digital humidity and temperature sensor, which tells us the current temperature of the machine. Now, the EcoRove not only just detects e-waste, it is also capable of detecting plastic waste. As you can see, now this plastic waste, this is our second machine, Plastic Manager, which converts plastic into smaller bits. So the first part of this machine is the contactless door, which promotes hygiene as it opens contactlessly. So it can be opened via two ways. One is the ultrasonic sensor and second is the Bluetooth method. The Bluetooth method is controlled via a self-designed app. So as you can see, when I press the on button, the door opens automatically. And when I press off, it closes automatically.
Go.
Now I'll show you how the ultrasonic sensor works.
Go.
I open the door using the ultrasonic sensor. After a brief period of time, the door will close automatically again. So now, as you can see, I demonstrated you two ways to open the door. Now I'll put the waste inside this machine. After putting the plastic waste in the plastic manager, it is shredded into further bits using two 12-volt motors and our self-designed PLA made shredders. So the waste, after getting shredded by the shredder, is collected in a collection tray below and is manually plastered, is transferred to our furnace. Here we put the plastic and switch on the furnace after putting a layer of glycerin to avoid adhesivity due to melting of plastic. Now as you can see, the furnace has already started heating. And we melt the plastic waste anaerobically by covering it from above so that no toxic gases are released into the atmosphere. Once this is done, a suction fan is switched on which sucks the gases from the furnace into a collection chamber.
There is a transformer which generates about 40 kilovolts. So there, the plasma generated by the transformer ionizes the air and breaks the hazardous substances into simpler molecular forms. Here is a demonstration of the plasma.
You can see we have also installed an MQI 135 sensor which detects the air quality index inside the collection chamber. And once the air quality index rises above 65%, which is toxic for human respiration, a buzzer automatically beeps signaling that there are toxic gases present in the environment. So once the plastic is melted and the molten plastic from this e-waste machine is transferred into this, in a fixed ratio 1:3, sand is added to this mixture, and it is transferred into a brick mold, and left to cool for some time. After some time, we get our very own echolith bricks. These bricks are extremely durable, and I'll also show you an example. You see, I dropped it from a height and still nothing happened to it. Now, I told you about the gases inside the collection chamber. So, what would happen with these gases? They pass through a very self-made filter which comprises of three layers: cotton, sand, and activated charcoal. The cotton captures large particles such as soot, dust particles, and the sand also captures soot. But the final layer, which acts as a very important catalyst, captures the partially burnt substances along with hydrocarbons. Then all of these three are cleared from the filter and they are cooked separately in beakers. So when activated charcoal is cooked with water in beaker at a very high temperature, it releases hydrocarbons. We sieve it and we get a black gooey liquid. And when we cook similarly cotton and sand, we obtain a soot liquid. All these three are mixed together, and a binding agent is added to it, such as gum arabica, starch solution, or honey, to keep it in the form of an ink and to keep it together. And then we finally get our very own air ink.